5-axis AlongCurve machining strategy. An AlongCurve machining strategy has been implemented for the 5-axis module. With this strategy, it is possible to machine along a curve and to either machine with the tool axis normal to the drive surfaces or to force the tool to follow a set of tool axis alignment curves. As with all 5-axis machining, the model files need to be loaded through the Granite Reader. Also, the face orientation for the surfaces must be checked to ensure the correct direction. The required curves may have been created by the CAD modelling software and included in the model files. If not, there are some tools in NCGCam to create the curves from the surface model edges. The first example has both the necessary surfaces and curves required. Let's open the model file, remembering to tick the option Use Granite Reader. Set any necessary fields in the project settings and click OK. To keep the contents directory tree view tidy, let's remove any surplus folders. Editable Boundaries 1 and Triangulated Points 1 are both empty folders and can be deleted. Let's inspect the surfaces. Select the triangulated surfaces and from the View menu, check the face orientation. This is to ensure that all the surfaces are the correct way round. The default colours are blue for the front face and red for the back face. We would hope only to see blue faces. In this case, there are red faces showing. These need to be selected and the directions reversed. Select the surfaces. From the Geometry menu, pick Reverse Orientation. Finally, to suppress the face orientation function, visit the View menu, Face Orientation Listing again. We need to create a folder containing the drive surfaces. Select the required surfaces. Right mouse click to display the menu, hold down the Control key and choose Label Geometry. This will create the Drive Triangulated Surfaces folder. We now need to arrange the curves that are needed into separate folders. Switch off the surfaces and switch on the curves. What we can see here is a profile that will be used to cut a window into the component and a set of 6 vectors that we can use to control the tool axis if we wish. Select the 6 curves that represent tool axis alignment vectors. Right mouse and choose Label Geometry. This will create a folder called Edited Triangulated Curves. This contains only the items we selected. Open the folder and inspect the contents of the tessellations list. What we are looking to see is that the curves are complete and represented as single items. There are 6 vectors on the screen and there are 6 curves listed in the folder. This is correct. We now need to confirm the direction of the curves using the function from the View menu, Curves, Direction Arrows. As you can see, these curves are pointing towards the surface. Note, they must point away from the surface, otherwise the system will attempt to machine the curves from the other direction. To reverse the direction, select the curves and from the Curves menu, select Reverse Curves. Rename the folder AlongCurves1. Suppress the arrows by revisiting the View menu, Curves, Direction arrows listing again. Switch off the alignment curves. Switch on the Triangulated Curves 1 folder and select it. Reselect on screen the 6 curves previously selected for the tool axis alignment and delete them. This folder now contains only the curves required for the profile to be cut. Open the folder and open the tessellations list. Here you will see there are many curves. These individual segments need to be joined into a single item. Select the folder. From the Curves drop-down menu, select Join Curves. The default values are suitable for this example, so click OK. Check the folder to confirm that the items have been joined correctly. We should have just one item in the list. Finally, rename the folder Profile Curves 1. I'm going to reorder the contents tree ready for machining. I have the drive triangulated surfaces, I have the profile curves, and I have my alignment curves. In the first example, we are going to machine the drive surfaces and the profile curves. Select them in that order. The tool axis alignment will be controlled by the drive surfaces and will be normal to them at the contact point. Right mouse click and choose 5-axis along curve. Select a suitable tool. On the passes page, check that the setup is correct. The output type is 5-axis, the strategy is projected, the cutting direction is climb. Tilt preferences are relative to the cut direction. The gouge testing is on, click OK. The toolpath has been created. Let's check the animation. The toolpath can now have the cutting parameters set and then post-processed in the usual way. In the second example, we are going to use the drive surfaces, the profile curves, and the alignment curves. With the alignment curves folder also selected, the tool axis will now be forced to align through the vectors contained within the folder. The folders must be selected in this order to achieve the correct cutting and guidance strategy. Reselect our cutter and check the passes page once again. The difference here is that the tilt preference is now set to tilt through lines because the alignment curves have been selected. Click OK to create the toolpath. An animation of the toolpath should confirm the alignment of the tool axis with the alignment curves. Let's compare this with the first toolpath. Here we can see the difference of the axis alignment between the two toolpaths.